Vertical scaling makes components bigger, but it leaves them as a single point of failure. For example, swapping out a single VM for a VM with larger capacity still means that VM can fail and potentially crash your service. Horizontal scaling makes services bigger through multiplicity. It leaves the unit capacity the same, but increases the pool of units. For example, instead of growing a larger VM, you could move to a design with a pool consisting of multiple smaller VMs. That not only makes it scalable, but resilient, because if one VM is lost, the others can pick up the workload until a replacement is added. There are several steps you can take to make your design resilient, and they're covered in this lesson.
So then we go into scalable and resilient design. So in this case, resilient design starts with health checks. You have to be able to monitor and understand, are we meeting our objectives? Is this up? Is this healthy or not? And there's a number of ways to check for health. We have both HTTP, TCP, SSL health checks, including custom health checks that are available with Stackdriver. So part two is to automatically replicate instances that have failed to or become unavailable, right? So a health check can do one thing, like in Kubernetes, if a pod is failing, it just simply restarts it, right? So that's its goal. Its health check is to just restart it until it comes back up. But you have to understand what, if something fails, you have to understand what new instances need to do. It's got to understand its role in the system. It should automatically configure itself, so it can probably pull in things like startup scripts, pull in environment variables. It can discover other dependencies, so what other processes should it be communicating with, and can it start handling those requests automatically? What about storage? Well, there's cloud storage, which is a great place to store state. We already handle the redundancy, the durability. It's virtually infinite in size. It has built-in multi-zone replication. So really, as a service, that's kind of taken care of. And Cloud SQL is also a great place to store data. It's a relational database. If you use the Cloud SQL service, as opposed to installing, say, MySQL on a VM, we have built-in replication that's available to you. It can replicate across zones, so you get that physical redundancy. Also does the read replicas to allow you to shard and kind of do some scaling with a single master. Then we get into the network, right? We have to build resiliency into the load balancers. Well, here's the cool thing. When you configure a load balancer in Google, a load balancer is not a thing. It's not a box like what you buy in your own data center. In fact, it's a distributed set of rules across our software-defined network. So that resiliency of those rules in that load balancer are actually multi-replicated in our software-defined network. So you don't have to build multiple load balancers and worry about protocols and failover between one device and another. These are already done for you. Same, except now you just worry about location. So if you're assigning virtual machines, make sure they're distributed across zones, perhaps even regions, depending on your DR strategy. But again, we make that very easy as well, especially our managed services. Take Spanner, for example. It automatically will configure nodes across multiple zones. So here's a design pattern. All right, so here we're going to use a general design for scalable and resilient apps using all of the best practices we talked about. So first we're coming in, we've got traffic that's going through our load balancer. Our load balancer is configured to route between virtual machines in multiple zones. And these are instance groups, so that allows them to auto scale up and down. There are templates to restart these. There are health checks in place, which is fantastic. If we now store state or other critical information in Cloud SQL, our Cloud SQL service also has reliable data because we've replicated that data. We can also store state in Google Cloud Storage. A multi-regional bucket will ensure that there's multiple replicas. It gives us a 99.95% availability uptime. So pretty resilient design. So what can it handle? Well, let's look at the scenarios, right? If a virtual machine fails, because we're in a managed instance group, we can automatically start up more machines based on a minimum criteria of how many should be running. If we lose an entire zone, our Cloud Load Balancer can then simply take over and route traffic. And if that zone comes back online, what happens if we lose our relational database? Well, fortunately, Cloud SQL has a resilient copy, so all of the VMs can quickly switch over to that. And then full disaster recovery. If we lose an entire region, which has never happened just yet, you can still have all of this data replicated. You can create snapshots, image repositories, store all of this in Google Cloud Storage. And remember, we've been doing a lot of work with the deployment manager. You can automate that failover process if necessary. You can rebuild the load balancer, the VMs, from the images, from the actual data on Cloud SQL. All of this can become from Google Cloud Storage backups, multi-regional replicas, etc., and automated using deployment manager. So you can see you can really, really scale this out to handle and accommodate many different kinds of disaster scenarios. So let's dive back in and talk about microservices and how we would design those for scalable and resilient streaming, as our example here. Well, in this case, we're streaming data into Cloud PubSub. This is our message queuing service. And now what we can do is process it with Cloud Functions. Cloud Functions is already a managed service. It automatically scales. You write one lick of code, and then, of course, it can scale to handle that for you. We can store data in cloud storage. We can also output data directly back to Google Cloud PubSub. So now we've got a mechanism that we can pass many different data outputs to different locations because PubSub can act as both the ingress and egress for our application. So here we're going to fall back into our 12-factor system design. So if we're designing applications in GCP, let's go ahead and review here how we can take advantage of this. So if we're treating backend services as attached resources, we can do so with our networking load balancer. If we want to export our services via port binding, number of ways to do that. We can expose an API through cloud endpoints. We can expose it through services in Kubernetes. We can also expose this utilizing load balancers. Our load balancers can obfuscate how many machines are on the back end, but we get this exposure through a single IP address and global IP address in some cases and port. We can execute the application as one or more stateless processes. This allows us to scale out via the process model. Again, we support that on many different platforms. GCE autoscaling with managed instance groups. So we'll automatically handle that. If a health check fails, if we start to see increased workload, App Engine already does that built in. There's no configuration hardly necessary. Cloud Functions. Again, auto-scaling service. Offloading the state. Now, we can store state in a number of resilient places. Let's just take Niantic and Pokemon Go, using Cloud Data Store to store that for their state and other information. Using Cloud SQL, maybe even Google Cloud Storage. So let's go and switch over back to process. So if we're going to keep development simple, iterative, and aligned, well, how do we do that? Well, we want common tools and systems across the organization. So microservices can really make this very simple. Continuous integration and continuous deployment. So Deployment Manager can really help with this. There's a number of different services that do support continuous deployment. And then developing IT enterprise processes. It's not fun, but the larger you grow, this is going to save a lot of people a lot of process and headaches. And you can take advantage of a lot of the learnings that Google has done throughout the years. So when we iterate on the design, we want to auto-iterate each release. So going through our system test, looking for bottlenecks, and always looking for ways to improve every time that we're going to be iterating and making changes to our process.
This module covered several related design goals, including reliability, scalability, and disaster recovery. The first subject was availability and reliability. A key concept is that planning for failure and dealing with failure in your design leads to improved reliability. Failure can occur due to the loss of a resource, or it can occur due to overload. You must be careful when making adjustments to a system that you don't accidentally create the potential for an overload failure when you're trying to improve resiliency to a loss failure. The second subject was disaster recovery, and you learned that planning for disaster and preparing for recovery is key. The third was scalable and resilient design, and that brings together many of the design principles you've seen in the previous modules and shows how they all fit together into a general resilient solution.